Okay. So the first question you've asked me to go over is number 25, where it asks you to find the inverse of a function. Did anybody go back and look at your pre-cal note cards about how to find an inverse? It's like a 3-step process. What's the first step?
Don't you put everything like onto this y, where you plug the y in the switch?
We want to switch x and y. So the first thing I would do for 25 is rewrite it using a y. So then we switch the x and the y.
And then solve for y.
Jordan. Thank you. So we switch x and y, and then you solve for y. So how would we solve this for y? And then divide by -2. So that tells me my inverse function, and do you remember the inverse involves that -1? It's not an exponent, that's the symbol for inverse. So our inverse turns out to be x minus 3 over -2. You could also write it as -x over 2 plus 3 over 2. So you could write that either way. So that takes care of the inverse for 25. If we were to look at number 27, again, the first thing I would do would be rewrite it using an x and a y. So I'm taking it out of function notation and using y instead of f of x. Now switch your x and your y. And now how am I going to solve that? Square both sides. Subtract the 10. Divide by -3. So that means our inverse function is, and you could write it as one fraction or separate it into two fractions. So you could write it as -x squared over 3 plus 10/3, or you could write it as that fraction there. Either way is fine. Number 31. So find an explicit formula for the inverse and use it to graph the inverse and the line y equals x all on the same screen. So you're going to do all of this graphing on your calculator. So first of all, notice it tells you a domain restriction. Why is that domain restriction important?
Because it can't.
Because it can't be 0. So
Okay, you're right, x cannot be 0 because of the x squared in the bottom. Why else is it important for a domain restriction with certain functions in order for them to have an inverse? What condition has to be met first before a function can have an inverse? It has to be a one-to-one function, which means it has to pass both tests, the vertical line test and the horizontal line test. Right? Okay, so this domain restriction occurs not only because x can't be 0, but also, notice it doesn't just say x cannot be 0. It says not only it can't be 0, but it also has to be greater than 0 to restrict it so that we're only looking at a one-to-one piece of the function. Okay, so we would want to switch x and y. And then we want to start solving for y. How would we do that? Okay, so now I have x minus 1 equals -2 over y squared.
And then you would multiply the y squared and then divide the x minus.
Great, so we're going to switch these places, right? We're going to multiply y squared over here, and then I'll divide by this binomial x minus 1. So we end up with y squared equals -2 over x minus 1. And when we do take the square root, what symbol should I be sure to include? Positive and negative. Square root of -2 over x minus 1. Now you've got to decide which one of these functions is really the right inverse. Do you remember what happens to the domain of your original function? What does that become for your inverse function? That becomes my range. So over here, I've got to make sure that my y's are greater than 0. So where would we end up with y's that are greater than 0 if we use the positive radical or the negative radical? The positive radical would give me y's that are greater than 0. So the inverse for this would be positive square root of -2 over x minus 1. Now you need to grab a graphing calculator, type in the original function. It asks you to type in your inverse function. It also asks you to type in this y equals x line. Is there a way on our calculator, though, to restrict the domain and only show us one piece of the graph? Bonus points. See if you can figure out a way. Yeah, we could change our window, but if I change my window, well, let's try it and see. Yeah.
Window.
But does that domain necessarily have to match the domain of the inverse? So we just want to make sure we can see enough of the inverse once we restrict our domain that way. So that's a good suggestion. So go ahead and change your window. Let's go from 0 to 10, and we'll see if that works for us. Okay, so hopefully y'all check that. Does that look right?
Yeah. Yes.
Okay, so you should have everything typed in, and when you press y equals, what zoom can I go to that would make this look a little more less warped? Zoom square. So from here I'm going to go to zoom square. Thank you, Wyatt. So am I interested in what's happening over here? The blue graph over here? No. But do I need to be able to see this red graph over here? I do, yeah. And by looking at this, does that remind you that the graph of an inverse is a reflection around that line y equals x, right? Okay, so you can see that this blue graph gets reflected. If we could fold this on that black line, the blue graph would be reflected over here with the red one. Does the red graph really stop here?
No.
No. What is it approaching? Infinity. Right. Okay. So we need to look at number 33. Okay. So use the given graph of f to sketch the graph of the inverse of f. So hopefully you were able to sketch this graph from number 33 onto your paper. And then I would consider this line y equals x. And then you're just going to try to draw the reflection of that. Like that. Ish. Close enough. So you just had to draw it based off that line. But then you need to draw in the line y equals x first, so that you could see the line that you're reflecting it about. Yes? Okay. All right. Yeah, Phaedra, come pause this while we get ready to move our next lesson and look at it. Look at it and see if it looks like you want it to.